Most organizations use open table formats for their data platforms. The decision on which open table format to take is usually driven by the vendor or by the specific use case, as some vendors favor one table format over another. In this video, we're going to see an end-to-end demo of how we can build a Lakehouse solution where we can easily convert between the different table formats, Apache Iceberg, Hudi, and Delta, so that we will end up with a solution where we will write our data in Hudi, then convert it into Delta and Iceberg, and then we can further read the data as a Snowflake table, for example, or register it in Databricks as a Unity catalog table. So before we start, let's look into the context very quickly so that we understand which problem we are trying to solve here. Nowadays, we are mainly talking about data lakehouse architectures, which are kind of a combination of data lakes and data warehouses, and try to combine the best of both worlds. As a quick recap, traditional data warehouses are not that flexible, so they're not really working well with unstructured data. They have this fixed schema. They work well for BI use cases, for example, but if we want to work with unstructured data or semi-structured data, that's most likely not that easy to do in data warehouses. That's why people came up with this concept of data lakes, where we just store our raw data there on cheap cloud object storage. And this opens up all of our other use cases where we might want to work with unstructured or semi-structured data, such as machine learning use cases. But now we have the problem in data lakes that we don't really have governance there. We also don't have the best performance as we are directly working on files. And also we have no asset guarantees and things like that we previously had in the data warehouse. So that's exactly where data lakehouses comes into play. We have our cheap cloud object storage, but additionally on top of our raw data, we have this metadata layer, which is the open table format. It's usually either Apache Hudi, Apache Iceberg, or Delta. Those three are the main leading open table formats. And with this approach, we have still our open, cheap storage. We have our asset guarantees provided by the open table formats. And this way, we basically combine the best of both worlds. So as I already said, the three most popular open table formats are Apache Hudi, which was developed by Uber. We have Apache Iceberg, which was originally developed by Netflix. And we have Delta, originally developed by Databricks. But now all of them are open source. So on a high level, we have overall the same structure for all of those three table formats. They differ in some functionalities, but overall, they all work with Parquet files as the data, and then they all have this metadata layer on top of it. So in terms of functionality, they are all very equal. There are some differences. So for some use cases, like change data capture, for example, it might make sense to go with one over another, but generally also one driver of the decision is which vendor people take or which data platform people take to process their data. For example, in Snowflake, we only have the possibility to work with Iceberg tables, so we are limited to that kind of. Now, if we look at the larger organizations, there may be a scenario that some teams or some people are working with one table format, another team is working with another table format. And now we want to kind of still have access to the data from their other team. One possibility would be to just read their raw Parquet files, but then we would miss out on all of the features provided by the open table format. And also if we are migrating from one data platform solution to another, we might have the scenario where we also want to change our open table format, for example, from Delta to Iceberg. So it would be great if we could just write our data once in any of those formats, and then we could just somehow convert the data into one of the other formats, ideally without touching the data, just changing the metadata so that the other compute engine or the other vendor also can work with that data. And this is exactly where Apache XTable comes into play, providing exactly this functionality so that we can, for example, start with Apache Hudi and just write the data for a specific use case in Hudi, and then later on we can transform the metadata to also, or convert it to also have the metadata for Delta and for Iceberg. And then we can also plug in basically different data solutions, different data platforms, Snowflake, Databricks, and work also with the other open table formats. And this is also exactly what we will be looking at in this video. So let's look first into the architecture, and then we will see a demo of an end-to-end solution with all of the format conversions and plugging in different compute engines and see how it all works together. All right, so this is the solution that we're going to implement. Let's go through it step by step. So in our scenario, imagine one team is working heavily with AWS. They built a Lakehouse solution in AWS, and now also other teams wants to access their data. One use case that they might have implemented is that they sync their relational database with their Lakehouse using a change data capture approach, and then storing the data in S3 as their Lakehouse solution in Apache Hudi table format. And now other people, for example, working with Snowflake, they want to access this data, but they want to access Iceberg tables and not Hudi tables. And same with Databricks, maybe another team wants to register this data as a Delta table in the Unity catalog in Databricks, but for this also the data needs to be converted from Hudi to Delta first. So the way this is implemented here is that we have RDS as our relational database. Then we have AWS Database Migration Service as like the service in between that captures the change data capture information from the source database and then sends it into a Kinesis data stream. And from here, we have a Glue streaming job running, which is basically an Apache structured streaming job under the hood, which is reading from that stream and then writing the data and applying the changes basically into an Apache Hudi table sitting in AWS S3. If you're not familiar with change data capture at all, I would recommend you to watch my last video. There I go way more into detail on how all of this works, why it is necessary, when it makes sense to use, and all those kind of things. But here, like keeping it only high level and focusing more on the conversion part. All you have to know, data is sitting in RDS in the database, and then it is basically written into our Lakehouse in S3 as a Hudi table. And now as the data is written in Hudi, in S3, we can just use, for example, a feeder or a Spark engine somewhere in Databricks, for example, to read the data, but only in Hudi. And if we want to use another table format, we need to do the conversion first. And this is where we are going to use Apache XTable to do that conversion from Hudi into Iceberg and Delta. And then we can use Snowflake, for example, and register an Iceberg table and read that exact same data. No actual data is copied or changed here. We are only additionally creating the metadata for Iceberg and Delta next to the Hudi metadata, basically. All right, then we can look into the demo next, and then you will also get a better understanding how all of this connects together and how an end-to-end solution would look like in practice. All right, so let's start in AWS and see what we have already here, and then we will go through it step by step. First of all, we have our S3 bucket, which is our data storage, basically our Lakehouse, where we will store our Hudi table, our metadata, and later on also our Iceberg and Delta metadata. It is called Interoperable Lakehouse here. Then let's see, what else do we have? We have an RDS database. This is basically our source database where we will pick up all of the change data capture information. This is a MySQL database, and here we will perform like inserts, updates, deletes, and these deletes will then be picked up by DMS, by Database Migration Service, where we have a database migration task over here, and it is already waiting for any changes happening on the source database. And once we do an insert or an update, this will be picked up by the database migration task and will be sent to a Kinesis data stream. Let's look into that as well. So here in Kinesis, we see that we have one stream, and this is the DMS CDC XTable demo stream. And this is then where DMS will send all the changes, so all the inserts, updates, deletes to this data stream. And then after that, we can look into Glue. So here we have several Glue jobs. One is the streaming job. So if we look into over here, this one is the Glue streaming job. And this will basically read the data from the Kinesis data stream, so it will recognize if new data is sent to the stream, and then it will basically, I don't want to go into too much detail of everything that is happening here. But you can also watch my last video on CDC. There I go a bit more into detail in terms of code. But here all you have to know is that the data is picked up from the stream, and then it is basically written into S3 as an Apache Hudi table. So also inserts, updates, deletes are processed here and applied to the target Hudi table sitting in S3. Okay, so before we start sending data to our source database, let's have a look into our S3 bucket just to see that it's empty. So we have our Glue scripts also stored here, but no data as of now is stored here. And now if we go into Glue again and start a job which will send data to the source database, it is this one over here, and let's just run it. So nothing too special happening here. That's just generating some mock data, utilizing the faker library, and then sending that data to our source database in RDS. And then again, basically DMS will pick it up, we'll send it to the Kinesis data stream, and then our in the background running Glue streaming job will write this data into our data lakehouse as Apache Hudi tables. All right, so let's see what happens here. Let's go back to S3 and look into our lakehouse. And here we see we already have a couple of files, also some Spark checkpointing things coming from the Glue streaming job, but our actual data is stored here in retail, then in ticket activity, and then we see, okay, we already have our Hudi data written here. We see our Hudi metadata folder, and we see that it's further partitioned by year, by month, and by day, and by hour. And then here we see our actual data as Parquet files. Okay, so now before we start converting the metadata from Hudi to Iceberg and Delta, let's have a look into the data first. For this, I will use Athena here, and then here we can see, okay, we have a couple of Hudi metadata in the data itself, but then we have like a ticket activity ID, sport type, sport date, things like that. And we can just easily query the data using Athena basically. Okay, next we are going to use Apache XTable to convert our schema from Hudi to Delta and to Iceberg. As you can see here, I'm on the GitHub page of Apache XTable. It's, as I said, an incubating Apache project. And all we have to do here is to clone this repository and then to execute some commands to make all of this run. And this is exactly what I did. So here on the left, you can see the cloned GitHub repository of Apache XTable. And then we need to do some configurations here in YAML, and then we can already start our conversion from Hudi to Delta and Iceberg. So all we need to do is create a YAML file here where we specify what is our source format basically, which is Apache Hudi in our case. We specify our target formats. So this could be either one or multiple of them. So here we have Delta and Iceberg. And then we also specify where our data sits. So in our case in S3, we specify our target table name and our namespace of our Glue data catalog. And then we are already up and running with this configuration. And then we have one more thing to do, which is the catalog configuration. So our goal is here to also govern our Iceberg table that will be generated in our Glue data catalog as well, so that later on we can also use that in Snowflake as an external catalog basically. You will see this later on. So that's why we also need to do these kind of configurations here. Basically just setting that we are going to use the Glue as our catalog implementation. And every time this process here runs, it will also update the Glue data catalog to basically point to the right metadata file from our Iceberg table. All right, and that's already it. So what we can do next is basically initializing this conversion process. And all we have to do for that is that we open our terminal. All right, and now we have to execute a couple of commands. So first of all, as this is a Maven project, we need to install our libraries that we need for the executable at the end. So we execute Maven clean package. For now, we skip the tests. And now we wait until all of our libraries are installed. In my case, it would just use the cached one, as I already executed this previously. All right, this was successful. So next we will execute maven install so that we build our jar file, which we will then after that execute to initiate the conversion process. So let's do that as well. Okay, here we see that it is not happy with something as we are missing some licensing information in one of the files. Yeah, for that we will just execute maven spotless apply. All right, now it's all fine. And now we can execute the jar that was created, which is the logic behind it to do all of the conversions. Of course, to make all of this work, you need to have set up your AWS configurations properly so that you can actually access your S3 bucket and things like that, and permissions needs to be set correctly. But all of that is already set up for me. So now I can paste this here, which will execute the jar. And here you can also see that I provided a dataset configuration and also this catalog configuration, where I just specify the name of the files I have here, those two YAML files. And now we execute this. And this should now convert our Hudi table into Iceberg and Delta. And then we will also see that in S3. Perfect, this is done. Sync is successful for Delta and Iceberg. So now let's look into S3. Here we go into S3 and look into our Lakehouse again. And here again going into retail ticket activity. And now we see we don't only have the Hudi metadata here, we also have the Delta log as well as the metadata folder, which is the metadata layer for Apache Iceberg. So now we successfully converted our originally written Hudi data into also Delta and Iceberg. So next, let's test these things out. First of all, let's look into Databricks here. I just set up a new notebook here, started a cluster, and I also, again, did all of the permission things in the background to have this connectivity to my S3 bucket. And now let's execute this over here, which is just, pure Spark to read the data as Delta. And let's wait until this runs. All right, it did work. So we can now see our data over here. And again, we read this as a Delta table. We originally have written the data as Hudi, but after the conversion, now we are able to read it as Delta here. And then now we can see exactly the same data that we saw earlier when we queried the data in Athena, the Hudi data, and now we can do that with Delta here as well. And now we could even register this table in the Unity catalog. But yeah, as this is an Azure Databricks account here and my data is sitting in AWS, that's not so easily possible. So let's next look into Snowflake. Here we also need to do some kind of setup to make all of this work first. So we're creating a database called XTable demo. We are creating a schema called retail. And then very importantly, two things we need to do to make all of this work is we need to create an external volume where we point to our S3 bucket and also specify the AWS role to access this data there. And the next thing that we need to do is to create a catalog integration, as we are planning to use our Glue data catalog as our Iceberg catalog. Now let's execute everything here, creating the database, creating the schema, the external volume over here, then the catalog integration as well. And now we can finally create the Iceberg table. So if we execute this over here, and also already selected right afterwards, we can see now we have also over here, we can see in the XTable demo database, in retail, we have this new table here, activity stream. And this is now an Apache Iceberg table that we can access in Snowflake, which is pretty cool because initially we just had this Hudi table. In Snowflake, there is also only Iceberg supported, so there wouldn't be the possibility to read the initial Hudi table. But as we converted it from Hudi to Iceberg using XTable, we can now read it here directly from Snowflake. All right, so this was already all I wanted to show. So we saw how we have a use case in AWS where it makes sense to write data in Hudi. Then we used Apache XTable to convert it from Hudi to Iceberg and Delta. And then we also saw how we can read the data from Databricks and from Snowflake in different table formats. And therefore, we are not anymore logged into one of the table formats. We can easily convert as we go and use whatever makes sense for our specific compute engine or for our vendor. All right, I hope you enjoyed the video. Leave a like and then I will see you in the next video.